Hello guys, thank you for watching our presentation. My name is Professor Eduardo Godoy. I'm an associate professor at the São Paulo State University in Brazil, and I will present our paper Microservice Orchestration for Process Control in Industry 4. So a summary of our paper, I will talk about the introduction, about theoretical concepts. I will talk about the service composition. I will present a little bit about the framework that we used for the developing the microservices, the molecular framework. I will talk about the types of service composition. If you want to create an application using several services, we need to do a composition. In the third part, I will talk about the microservice control of an industrial plant. I will present the pilot plant that we created to test the service-oriented architecture. I will describe the service that we developed. In the second part, I will talk about the orchestration or the composition of the service that we created to control the industrial plant. In the fourth part, we talk about the experimental results. In the first part, I will talk about the measurements about service execution and also communication times. And in the second part, I will talk about the control analysis to see if we can achieve a good control performance using the microservice application. And finally, the conclusions of our paper. So in the first part, the introduction, we talked about the context, the architecture, and the goals. So when you talk about Industry 4 represents the evolution of production systems through the union of operational technology and information technologies. And some challenges related to Industry 4 applications are the vertical integration of industrial systems and also the connectivity and the resource decentralization. So in order to meet these requirements, we can see an evolution of industrial architecture over the last years. So in the first architecture, we had centralized with peer-to-peer communication between equipment. In the second and third architectures, we had the adoption of communication networks. So we had the networked systems with distribution of control, with ease of commissioning and maintenance. In the fourth and current architecture, we have the cyber physical systems and cloud computing, leveraged by the integration demanded by the industrial Internet of Things and the Industry 4. When we talk about the service-oriented architecture that I will call in this presentation for SOA, we can see that there is today a migration from the traditional hierarchical and rigid industrial architectures. So in the first picture, we can see this like a pyramid. So we have an hierarchical layers for the automation systems. And now we are going to see a migration from this architecture to a new architecture that we have an automation cloud. So in this architecture, all the equipment, all the systems, and all the resources are provided in the same cloud infrastructure. So we have an interoperable way for them to communicate, okay? When you talk about service-oriented architectures, services are provided to other components through a communication protocol. And what is the service? Service, it's like a piece of software. It's a functionality. And this piece of software implements a required functionality in an application that we want to develop, okay? And finally, the microservices that we are using in this paper. Microservice is a SOA variant, so it's an evolution of SOA. And in this kind of application using microservices, the applications are decomposed in couplet and small services, which offers greater modularity and simplifies the development, okay? So the goals of our paper were to demonstrate the potential of service-based architecture for industrial applications. So we want to show the advantages of using this kind of architecture for industrial applications, the potential. We want to investigate the microservice composition for process control applications. So we want to see if we can create applications using microservices for process control applications. And finally, we want to discuss experimental results concerning the orchestration of microservices for the control of an industrial pilot plant. So we want to discuss the results in terms of service execution times. We want to control performance in order to see if we can use this type of composition, that is the orchestration of microservices to be applied for process control. So in the second part, we will talk about the service composition. So we talk about first the molecular framework and after about the composition of the service, okay? So in this work, we are using the molecular framework. So the molecular framework, it's an open source framework for developing microservice applications using JavaScript and Node.js. This framework is based on request and reply concept, and with also support to notification of events. This framework has some functionalities too. So we have, for example, the automatic service registry and discover. So if you create a new service, this service is automatically registered on the infrastructure, and communication procedure is done in order to communicate all the other services that a new service is available, and all the discovery procedure in order that the other service can request this new service. Okay, we have a load balance requests and events among services. So if you have more than one instance of a service in the infrastructure, the framework automatically balances the requests among the services in order to achieve the best performance. And also we have many fault tolerance features in order to achieve a reliable communication among the services. If you look at the infrastructure of the molecular framework, the main components, we can see a microservice container in blue in the figure. So we have like a template, like a container, so we can put our code inside. It's easy to develop. We have several transporters. The transporter is responsible for the network communication inside the framework. So we don't need to program anything about the communication. We can just select each kind of transporter we are using. So we have several options such as TCP/IP, MQTT, and NATs. And finally, we have a standard API gateway for external integration. So if you want to integrate our microservice architecture with external applications, this is already done using the API that is available, okay? So if you want to create an application using more than one service, we need to do a service composition. So we have two types of service composition. We have two ways to do that. The first one is shown in the picture, is the orchestration. So in this orchestration, we have always a conductor. It's like the maestro of an orchestra. And this conductor coordinates the call of the other services to compose a more complex functionality. So the conductor is the central piece of the coordination. And also in the second type, we have the choreography. So that's shown in the picture in green. So the sequence of services in the execution is predetermined. So it's determined before the execution of the application. And each service knows how and in which to communicate with others. So there is a sequence predetermined, and there is no need to have a central conductor like in the orchestration, okay? In the third part of this presentation, we'll talk about the microservice control of industrial plants. So we'll talk about the service that we develop within the industrial plant, and also the orchestration or the composition of our application. So this is the picture of our pilot plant that we developed in our project. So it's a traditional pilot plant with several different variables, process control variables. We have level, we have temperature, we have pressure, the pipe pressure, and also the tank pressure, and we have also level. The difference of this pilot plant is that the architecture is based on service, so it's a service-oriented pilot plant. Okay. So for this paper, we have developed some service in order to use and apply for a control loop. So we have first developed a DAC service. The DAC service is responsible for acquiring the data of the variables. Okay, so we are using a Raspberry Pi with an expansion boards in order to connect the sensors and actuators. We also develop a control algorithm. So we are using a PID plus control algorithm. It's developed under the PID service. It's running also in a Raspberry Pi. We also have another Raspberry Pi running the API service, the API gateway service, and also the transporter server that we are using this paper, the nets. And finally, we created an external application using LabVIEW in order to orchestrate these services, the four services that I talked before, in order to create the control loop for process control, okay? So for this paper, we focus on the line pressure control. So we can see in the picture the pipeline in red and also in blue the pressure sensor and also the pump. So our actuator is the frequency inverter with the pump. So for this orchestration, we need to use these services and we need to orchestrate how they are going to operate the sequence of execution. So we can see the numbers in this picture. So 1, 2, 3, 4, 5, 6. We can see all the execution of the control loop. So the control loop, the sequence is managed by the orchestrator, that in this case is the external application. So now we can see the experimental results. So we can see some metrics about the operation and about and also the graph. So that orchestration that I said before, now we are representing the times. So we can see the same flow of information going from the external application, passing through the API and the transporter going to the DAC sensor. So we want to take the information from the sensor. It goes back to the application, and also it goes from the application to the PID control to calculate the new control signal, and goes back to the application, and from the application it goes to the actuator to apply the new control signal to the plant. So each one of these diagram represents a control cycle of the control loop. Okay, so we have measured the times of each one of these times, T1 to T7, representing the several different times about the control loop. And we have measured these times using wireless communication, Wi-Fi, and also cable communication, Ethernet cables, okay, among all the services. So this is the table about all the results that we have. And the first thing that we figured out is that the communication time, the time consumed by the API and also by the transporter, are much higher than the service execution times. So the time to execute the service is much smaller than the time used by the communication in each one of the control cycles. So now in the second part of the experimental results, we can see the output response of the line pressure control system. We can see that we had an adequate control performance with reference tracking and minimization of the error. And also we calculated the orchestration cycle time. There is the sum of the times of during the execution of the orchestration. And we could see that the value is fast enough and compatible to control applications. We had a value of 62 milliseconds for the wireless connection and 51 milliseconds when using the wired connection. So these values are fast enough and compatible to any process control application. And finally, we talk about the conclusion, some future work in my content. The conclusions. So service-based architectures are the new reality for Industry 4, providing vertical integration and communication interoperability. Microservices are simple, are flexible and modular. So when you use microservice, the development of microservices are very simple. It simplifies network communication, as I said, because there is no need to program, to code in network communication. It's network communication using the transporter is transparent. We don't need to program anything. And also there's a great flexibility because we can create new services and we can create new applications composing this service. And finally, experimental results concerning the microservices execution and communication proved that the orchestration control time is compatible for process control applications. So we saw that until control cycle time of 300 milliseconds, the microservices orchestration is enough for this kind of application, and we saw the control performance of the results. For future work, we are planning to compare the results of this paper using orchestration with new ones using choreography for the same case. So we want to compare the difference between the composition of the control application using orchestration and choreography. We want to implement some security implementations for the microservice-oriented architecture. So we want to implement service access control. We want to secure external access to services, and we want to secure services requisition. Okay. So if you have any questions regarding this presentation or about the paper, please contact me. So you can see my email on the screen. So let me know and we can talk about it, okay? Thank you very much for watching this presentation.